Alright then, let's see packing in 3 dimensions. Okay, now in 3 dimensions there will be a horizontal arrangement, there will be a vertical arrangement, and there will also be a 3D arrangement wherein we are also giving the height to the structure. Alright, once again in 2D we have already seen we have 2 types of packing, that is square closed packing and hexagonal closed packing. So in 3D also we are going to have 2 different types of packing. From 2D packings we are going to generate a 3D packing. Okay, let's see. The first one, we are going to take a layer of square closed pack 2-dimensional layer, and we are going to stack the layers just above the first layer. Alright, we are just going to keep stacking one above the another, not covering the voids, but we are just stacking one above the other. And what you will observe is that all the layers, they are basically vertically aligned. Okay, great. Then if you just try to see the smallest repeating unit, you will observe over here, what you will observe is, if these are the atoms and these are the centers, there's one atom behind this one, right? And there's one atom behind this. So if you just draw the smallest repeating unit, you will observe that this is something like a simple cubic unit cell. Yes, so in square closed packing, ध्यान से सुनिएगा मेरी बात को, square closed packing in 3D, the unit cell that is developed is nothing but simple cubic unit cell. Alright, now understand first point. Second point, we remember in simple cubic unit cell the coordination number was to be 6, right? And you can prove it also. You take any atom in simple cubic unit cell and just see what are the direct atoms which are being surrounding the target atom. You will find that the coordination number is 6. We have already done this, right? Then point number 3, this is very, very important. If you see, if this whole layer was named as A, then the same arrangement is of this layer, so this is also called as A. The same arrangement is of this layer, this is also called as A. The same arrangement is of this layer, this is also called as A. So hence this type of packing is also known as AAA type of packing. Why I have written dot dot? Because this particular repetition keeps on going indefinitely in 3 dimensions. Is that clear? So this basically is your what mere bachche, square closed packing in 3D. Correct? Perfect? Alright, next ahead is hexagonal closed packing in 2 dimension. Now if you remember, hexagonal closed packing looks something like this, correct? Wherein these voids over here, they were known as triangular voids. These voids were known as triangular voids. Now this is the first layer. Now we are going to stack a layer above this. Correct? So let's name this layer, the first layer, as alignment A, which is of red spheres. Correct? And these are the triangular voids which were developed. But out of these triangular voids, we can observe that not all the triangular voids can be filled up. Only which triangular voids will be filled? These triangular voids will be filled. Okay, so what are we going to do is, we are going to now place a second layer. Please remember this, what I am trying to say, we are going to place a second layer. Above this layer. Perfect, the first layer. But if you observe, the moment I try to put a second layer, let's say over here, this layer is not going to have alignment with the first layer, right? And that's the reason when I put the second layer, I color them as blue. Why I have colored them as blue? Because this layer is not having a same alignment as that of the first layer. Perfect. But now if you observe something over here, you will see that you are not able to see all the voids that are being developed after the placement of the second layer. So what I have done for you is I have just made this second layer as transparent layer. Alright, so now clearly you can see the voids that are developed. Now there are two kinds of void. One kind of void is something like this, which is 1, 2, 3 and 4, surrounded by 4 spheres. And one kind of void is this, which is surrounded by, once again, 1, 2, 3, 4, 5 and 6. अच्छा चलो इसको थोड़ा सा डिफरेंटली लिख लेते हैं. 1, 2, 3 and 4, blue wala 4th, right? One void. And let's highlight the other void over here, wherein you will see 1, sphere 2 red, sphere 3 red, once again 1, sphere 2 blue, sphere 3 blue. So you will see 6 spheres. It is surrounded by 6 spheres. Alright, perfect है. तो यहाँ पर आपके दो तरह के spheres बनेंगे. There will be, sorry, two types of voids which will be formed after the placement of second layer in hexagonal close packing. There are two types of voids formed. What are those two types of voids? Those two types of voids are known as tetrahedral voids and octahedral voids. Yeah, so these are known as tetrahedral voids and these are known as octahedral voids. Is that clear? Perfect. So this is how the packing looks like, layer A and layer B. Perfect. Now tetrahedral voids, they are surrounded by 4 spheres, 1, 2, 3 and the one on the top. Now if I just make this atom smaller and join the centers of these, you will see a perfect tetrahedral being formed. Is that okay? Clear? Now just observe this. In the center of this tetrahedral, the void is lying. There is an empty space in the center of this tetrahedral. Is that clear? Perfect. So this is how a tetrahedral void looks like. Perfectly okay? Great. Then this is known as tetrahedral void. Then we talk about the octahedral void, which is surrounded by 6 spheres. Now some students are already going to ask me, sir, why it is known as octahedral? Tetrahedral में तो 4 spheres थे, यहाँ तो 6 spheres हैं, तो ये तो नाम कुछ और होना चाहिए था. Why it is known as octahedral? तो याद रखिएगा मेरे बच्चे, hedral means faces, right? So over here also you will not see the spheres. You will see that on joining the centers of those spheres, a diagram is formed, a figure, a shape is formed which has 4 faces. It has 4 faces. That's why it is known as tetrahedral void. Similarly, when I just make these atoms smaller over here and join the centers of these, you will see a perfect octahedral being formed. Is that clear? And this octahedral, you see, 1 phase, 2 phase, there is a phase behind this and there is a phase exactly over here. So this 4 spheres, correct? So 4 up, 4 down, and in the center over here, this void is basically lying. Is that clear? Perfect. Yes. See, there's atom number 1 over here, atom number 2 over here, atom number 3 over here. Atom number 4 will be the 4th corner of this square, right? This square which is being formed. And atom number 5, atom number 6. So atoms are 6. There are 6 atoms. So if anybody asks what is the coordination number of octahedral voids, that is 6. But why it is known as octahedral? Because on joining the centers of those 6 atoms, a perfect octahedron is formed, and hence it is known as octahedral void. Is that clear? Perfect. Are you sure with this? Good. So now the question is, sir, पहला layer था हमारे पास, that was very simple, which had triangular voids in it. उसके बाद हमने second layer रखा, उस hexagonal packing के अंदर हमने second layer रखा. But second layer रखते ही I have been found that I have 2 types of voids. One is tetrahedral voids and one is octahedral voids, right? So now when we are placing the third layer, we have 2 choices. Either I can cover tetrahedral voids or I can cover octahedral voids. Are you getting my point? Right? Either I can cover a tetrahedral void, either I can cover a octahedral void. So now what we are going to do is, we are going to start placing the third layer. Condition number 1, where we are going to cover the tetrahedral voids. Condition number 2, where we are going to cover the octahedral voids. And you will see that just by placing or by changing the voids, right, sphere placement, we are going to do 1 on tetrahedral voids, 1 on octahedral voids. We are going to observe that in both the placements, the packing is having some different kind of unit cell. Is that clear? Perfect. So placing the third layer now. Now, when we want to place the third layer, this can be done in 2 ways. Wherein, what I can do over here is, I can simply either cover the tetrahedral voids or I can cover the octahedral voids, as we discussed, right? So condition number 1, we are going to cover the tetrahedral voids. We are going to cover the tetrahedral voids. Perfect है? Clear है ये चीज? Good. अभी ध्यान से observe करिएगा. Just observe very keenly. These are one kind of tetrahedral voids, correct? And similarly, there is another tetrahedral void over here. There is another tetrahedral void over here. This is also surrounded by atom number 1, 2, 3 and the 4th one, that is down below. So एक tetrahedral void आपको ऊपर से दिखता है और एक tetrahedral void आपको नीचे से दिखेगा. So what we are doing is placing the third layer, and this time in placing the third layer we are going to cover up the tetrahedral voids. Now when we cover the tetrahedral voids, what we observe, when we cover the tetrahedral voids that are highlighted over here, what we observe that when we place the third layer, it is exactly same as the first layer, that is alignment A. So what we observe over here, that the first and the third layer, they have the same alignment, and that is alignment A. We had named it alignment A, right? Now on the similar conditions, now there is a tetrahedral void developed over here. See this, 1, 2, 3 and blue wala 4. Similarly, tetrahedral. So on the similar conditions, we are going to stack up the further layers. Now when we do that on the similar conditions, we observe that the fourth layer we are putting, that is exactly same as the second layer, that is alignment B. So finally the packing looks something like this. Very important. Yes, this was alignment A, this was alignment B. Once again, on placing the third layer covering the tetrahedral voids, we got alignment A over here, and similarly when we place the fourth layer, we got alignment B over here. Is that perfectly clear? So this type of pattern is known as AB type of pattern when you are covering all the tetrahedral voids. Now let's just make these atoms smaller and join with them with the straight lines. What we observe? We observe that the smallest repeating pattern that can be brought about from these is nothing but a hexagonal unit cell. Is that clear? So hence this packing is known as hexagonal closed packing. Correct? Let me just write down. We call this as hexagonal closed packing. What's the unit cell? Unit cell is nothing but hexagonal unit cell in this type of packing. This type of packing is also known as HCP packing for short. Second, कई बार ऐसा पूछ लेते हैं वन मार्कर में क्वेश्चंस दैट हाउ मेनी एटम्स आर देयर इन एन हेक्सागोनल यूनिट सेल. सिंपल क्यूबिक में हमको पता है एटम्स 1 होते हैं, एफसीसी में पता है एटम्स 4 होते हैं, बीसीसी में पता है एटम्स 2 होते हैं. हेक्सागोनल में लेट मी जस्ट सी 1 2 3 4 5 6 there are 6 corner atoms up and 6 corner atoms down, so total 12 corner atoms, but these 12 are corner atoms are not shared by 8 unit cells, they are shared by 6 unit cells, plus there are 2 body centers 1 and 2 which are shared by 2 face centers which are shared by 2 unit cells, so 1/2, plus there are 3 body centers 1 2 and 3, so 3 into 1, so you get the total as 2 plus 1 plus 3 and the number of atoms are 6. Now this number is important, nobody is going to tell you to prove this, but हाँ पता होना चाहिए कि एक hexagonal unit cell is shared by 6 other unit cells, not 8. Is that clear? And we can prove this also. देखो मैं सिंपल एक हेक्सागोनल बनाता हूँ ऐसा. अब एक कॉर्नर एटम को इमेजिन करिए, अब इसके बाजू में देयर इज वन मोर हेक्सागोनल यूनिट सेल लाइक दिस, राइट. इसके बाजू में देयर इज वन मोर हेक्सागोनल यूनिट सेल ओवर हेयर, राइट. सो यूनिट सेल 1 2 3, this atom is shared by 3 unit cells in the plane, एंड ऐसे ही 3 यूनिट सेल इसके ऊपर होंगे, राइट. सो टोटल ये कॉर्नर एटम्स कितनों के साथ शेयर हो रहा है? 6 यूनिट सेल्स के साथ शेयर हो रहा है. दैट इज व्हाट आई डिड, 12 into 1/6 because corner atoms are being shared by 6 unit cells. So this is what you observe, this is what you get when you place the third layer such that you are covering all the tetrahedral voids. Is that clear? So this is very very important. So once again, when you're covering all the tetrahedral voids after the placement of second layer, you get an HCP packing. HCP packing ka coordination number is again 12. The coordination number is again 12, same as FCC. Third, very very important, the unit cell that is formed over here is a hexagonal unit cell. Very important points. Please make sure that you write down these points in your notebooks. And fourth, how many atoms are there in an hexagonal unit cell? 6. Correct? Are you sure with this? Good. Alright. Another way of placing the third layer. Now we are talking about the third layer. This is very important. पहला चीज हमने देखा जब हमने tetrahedral voids cover किए. अब another way of covering this is when we cover all the octahedral voids. Okay, so the second way is to cover up all the octahedral voids. So this is where I have highlighted all the octahedral voids. But when you place this layer, we observe that it is neither matching with the first layer nor with the second layer, and hence I have given a different color to them, that is green color. Is that okay? And when we observe this packing, we observe that the first layer is your A type, the second layer is your B type, and the third layer is your C type. अब बारी आती है कि फोर्थ लेयर कवर करने पे, फोर्थ लेयर में कंडीशन वही ऑक्टाहेड्रल वॉइड्स ही कवर होंगे. क्या होंगे? ऑक्टाहेड्रल वॉइड्स. सो दिस इज वन योर ऑक्टाहेड्रल वॉइड, दिस इज योर ऑक्टाहेड्रल वॉइड, दिस इज योर ऑक्टाहेड्रल वॉइड. इज दैट क्लियर? सो कंडीशन वही रहेगी. सो वी आर गोइंग टू place the fourth layer now and see if there is a repeating pattern. All right. So the third layer is alignment C, and now covering the octahedral voids while placing the fourth layer, we observe that they exactly match with the first layer. They exactly match with the first layer. So the spheres of the first and fourth layer, they are exactly same. So when they are same, we call this pattern type as ABC type of pattern. Yeah, see, ABC was the first, and then once again ABC is repeating, and this keeps on repeating. And when we just make the atoms smaller, and we join them with the straight lines, we find that the unit cell, the smallest repeating pattern in this type of packing is nothing but an FCC unit cell. क्या मिलता है हमको? एक FCC unit cell, and hence this kind of packing is also known as cubic close pack structure or an FCC structure. Very very important. मैं दोनों यहाँ पर लिख देता हूँ. थर्ड लेयर प्लेसमेंट में प्रॉब्लम आया था वेयर वी हैव टेट्राहेड्रल वॉइड्स एंड ऑक्टाहेड्रल वॉइड्स. तो अगर हम टेट्राहेड्रल वॉइड्स कवर कर रहे हैं तो नंबर 1 HCP पैकिंग बनता है. नंबर 2 यूनिट सेल इज अ हेक्सागोनल यूनिट सेल. करेक्ट. नंबर 3 we have nothing but the atoms is nothing but 6, and fourth the coordination number is 12. Very important. This type of arrangement is AB type of arrangement. We saw that, right? But when we cover the octahedral voids, what we find out that first of all the packing is known as cubic closed pack structure, which is also for short known as CCP, or sometimes it is also in some books it is named as FCC structure. Why? Because the unit cell that is formed is a face centered cubic. That's why it is cubic closed pack structure. Is that okay? Again, the number of atoms in an FCC is 4. The coordination number in FCC is again 12, but this time the arrangement is ABC type of arrangement. So these were the two types of packing that we saw. In hexagonal 2D arrangement, when we are trying to make it a 3D arrangement, two types of voids, tetrahedral, octahedral. If we cover the tetrahedral voids, we get the packing as AB type, whereas if we cover the octahedral voids, we get the packing as ABC type, and the difference between the both is right there on your screen. These points are very very important. Please make sure that you have 100% noted down all these points over here. Is that clear? So with this, the packing portion is over. But अभी भी सर पैकिंग तो हो गया, लेकिन कितना परसेंटेज पैक होता है और कौन सा सबसे बेस्ट है? वी नीड टू नो द बेस्ट पैकिंग इज इन विच काइंड ऑफ यूनिट सेल. इज इट FCC? इज इट HCP? इज इट सिंपल क्यूबिक या स्क्वायर क्लोज पैकिंग जो हमने देखा था, राइट? SCP, स्क्वायर क्लोज पैकिंग. सो इन तीनों में से किस में सबसे बेस्ट पैकिंग मिलता है? तो उसके लिए वी हैव टू डू अ वेरी वेरी इंपॉर्टेंट टॉपिक दैट इज नथिंग बट पैकिंग एफिशिएंसी. ऑलराइट, एंड दैट इज व्हाट वी आर गोइंग टू डू नेक्स्ट. बट बिफोर वी मूव टू द पैकिंग एफिशिएंसी पार्ट, देयर इज अ वेरी इंपॉर्टेंट थंब रूल दैट यू नीड टू नोट डाउन. हाँ, हम ये कैलकुलेट भी कर सकते हैं, बट अभी के लिए वो कैलकुलेशन ज़रूरी नहीं है. आपको बस इतना याद रखना है कि अगर एक टाइप ऑफ पैकिंग में देयर आर n atoms which are being packed, n atoms are undergoing packing. That packing can be either an FCC packing, that is cubic close packing, or it can be an HCP packing. So if a solid is undergoing FCC packing or HCP packing, then the number of tetrahedral voids. The number of tetrahedral voids in that is twice the number of atoms that are undergoing packing. And the number of octahedral voids are exactly same as the number of atoms that are present in the solid. Is that clear? This is very important because this thumb rule is going to be utilized for a very important question, that is nothing but formula of the compound. Derive the formula of the compound, wherein it will just say that there are two atoms. The solid is made up of two atoms, let's say A and B, and it will say that A undergoes packing, A atoms undergo packing, and B atoms occupy all the tetrahedral voids, So what you're going to assume is that if A is undergoing packing, you will assume that as there are n atoms of A is to B atoms, it is occupying all the tetrahedral voids. So with respect to n atoms, there should be 2n tetrahedral voids, and all the tetrahedral voids are getting occupied by B atom. So n and n gets cancelled. You get AB2 as basically the formula of the compound. Similarly, it can put a condition over here. Just giving you an insight, we will do the numericals later on in another online classes, but over here just understand, if A and B are the two atoms being packed in the solid, A is undergoing the packing, the major packing is undergone by A, and B occupies only 1/3 of the tetrahedral voids, only 1/3, not all, but this time the condition is only 1/3. So in that case, what can you do? Just see, just observe over here. I'll assume that A atoms over here are n. With respect to that, the tetrahedral voids should be 2n. But out of that 2n, there is only 1/3 being covered by B atoms. So 1/3 of 2n, wherein n and n get cancelled. You get the ratio as 1:2/3. Now, atoms cannot be in fraction. So what we do is we multiply this by 3. We multiply this by 3 to make it a simple whole number ratio. You get the ratio as 3:2. Now the formula becomes A3B2. Alright, so this condition of the void given is going to be very useful, and this is how basically the formula of the compound is formed. Is that clear? So in the next lecture, we are going to talk about packing efficiency, and we are going to see how different unit cells have different packing efficiencies. Till then, please take care of yourself, stay tuned, and keep smiling. Be positive. Bye-bye.